I'm building Angular applications for our internal team. We have multiple teams to do the content of our website, and those teams, the members of those teams, have almost every time they have a browser with multiple tabs of all our applications, YouTube, whatever, and so ever. And the thing is, their computers are not like mine. Mine is a 16 gigabyte quad-core processor MacBook. Like almost all developers, I have a quite good computer. Their computer is what I would call a low-end device. That means they have 1 to 2 cores, 2 to 4 gigabytes of RAM. And with that in mind, and if you think that they have a lot of tabs open with various Angular applications, you have to think about performance. And one way to think about performance is to think about lazy loading and preloading strategies. So who am I? That's me. That is my name. My name is Martin. I work for a company called Idealo. We are doing price comparison in Germany and various other European countries. And at Idealo, I'm building internal tools to fill the content of our website with stuff. I'm also an organizer of the Angular Berlin meetup, so you can find me at almost any community meetup in Berlin or hackathon or something like that. I really enjoy the community in Berlin, and I really enjoy the community in various other cities in Germany. So when we talk about what I love Angular. I started with AngularJS 1.07. Before that, I was a backend developer. I love math. That's probably the reason why I studied math. And I love cats. That is my cat. And luckily, his nickname is my Twitter handle. So as Asim just said, if you want to follow me on Twitter or want to ask me anything on Twitter, just go to Chaos Monster and ask me. And that is the only cat you will see. Yeah, I'm sorry, I didn't prepare more cat slides. Let's start by performance and lazy loading. This will be a short recap about lazy loading in general and performance in general and preloading strategies before we go in a little bit deeper into what a custom preloading strategy would look like. Lazy loading is a great way to optimize your startup performance. So your initial app size gets a little bit smaller. That means your app starts faster and loads afterwards everything it needs. There are a lot of great articles how to do that by Victor Safkin, Manfred Steyer, who did his talk yesterday, and maybe we will hear something about it in the talk that comes after mine. The thing is, those lazy loading modules, lazy loading needs modules that have their own routes. So those lazy modules, I call them in the slides routing modules. Maybe not the best choice, but well. And you can use preloading strategies to manage the fetching of those lazy modules. So lazy loading in a nutshell. It's super simple. Everybody should know about that. We won't go too deep into it. You have to have a module, and this module has to have its own routes, and it passes it to the for-child method of router module. So this is a lazy module, and if you want to load this, or this is not a lazy module, this is a module with its own routes, and if you want to load it, you have to have in your for root routes something like load children with a relative path to the file where the module is, the module name, you're done. You can additionally add some data. This can be a JSON object with anything inside. So that was lazy loading in a nutshell. If you do that, you have lazy loading done. The next thing to think about is preloading strategies. There are two built-in preloading strategies with Angular, the preload nothing and the preload all strategy. The preload nothing strategy is the default one. So what happens every time you go to a URL that represents a lazy loaded module, Angular will load the module in the back and will initialize it and start it. The opposite is PreloadAllModules. What that does is, as soon as this Angular core application you build started, it starts fetching all lazy modules you created. You can pass the preloading strategy as a second parameter to your for root method on router module. This is nothing new to everybody who's in this room, I hope. If so, I'm sorry, because I'm skipping over that again. Custom preloading strategies, in a nutshell. That means you have to have a service that implements the preloading strategy interface. And this preloading strategy interface gives you a method called preload with the route of the lazy loaded module and a function that you have to call if you want to load this module. It returns an observable, so the interesting thing is either you want to execute the load function to load the lazy module, or you want to return an observable of null if you definitely don't want to load it. What we have to think about is observables mean we don't have to decide right at this point. We can defer the decision on if we want to load this module to a point in the future. And we will use that for more advanced custom preloading strategies. So what are the scenarios you could think of when it comes to more advanced custom preloading strategies? As I just said, low-end devices. For example, my colleagues at the content team, they have low-end devices, they have low-end desktop devices, but you also can think about low-end mobile devices. I have an iPhone. I think that's not really a low-end mobile device, but there are low-end mobile devices out there, not only in various countries, but you have to think about them. And if you think about them, you also have to think about slow connection, because not everywhere in the world you have 3G or Wi-Fi or something like that. So for example, if you go outside of Berlin, just a few kilometers, you don't have any internet connection. So yeah, they have slow connections there. And the third thing you may think of when you're going to talk about scenarios for custom preloading strategies that are more advanced are large applications. For example, if you're a really large application with many lazy modules, you can think about, okay, if I load everything, all of the code I have will be 2, 4, 5, 6, 7 megabytes. That can really happen if you have a large application. And if you're a customer or your user has a low-end device, the JavaScript engine starts swapping because the memory is too full and stuff like that. So you don't want to load everything. You want to load the things you really need. Or, of course, a combination of all those three. I want to point out this quote. It's not about Angular, and it's not about preloading and lazy loading, but there's one really important message with this quote. You can't use what I'm going to do to make things quickly or stuff like that, but it's really just to make big, difficult things a little bit more easy, like being resourceful with your users' resources. And what I'm going to show you, you shouldn't think about it if you're just having a small to-do app or something like that. Think about it if you're having a larger application. So let's start with the slow connection. Wouldn't it be awesome if our browser has an API that tells you you're on a 2G, you're on a 3G, you're on Wi-Fi? Well, it turns out there is an API for that. It's the navigator, window.navigator connection. And the connection itself has a few more properties. One of the most important ones is the effective type. And the effective type just returns a string for 4G if it's a big application, if it's a fast internet connection, 3G, 2G, or slow 2G. And you can really use this in your Chrome and go to your Chrome, to the console, type in navigator connection, and it will show you your true internet connection. If you use your console and you change the performance of your throttle your internet connection in the browser console, you will also see that it really works. But it's experimental and it only works in Chrome. I do not know if it's working in Opera. Definitely not supported in Internet Explorer and definitely not supported in Safari. So yeah, would be awesome, but if you're not sure that all your users are working on Chrome, you shouldn't rely too much on that. Another way is to use timeouts. We are here in the part where it's not about precise prediction what internet connection you have. This method wouldn't tell you you're on 2G or you're on 3G or on the Wi-Fi. This method would just give you a rough idea of, okay, my connection is really slow or my connection is quite fast. So the idea is you have a timeout in your index.html file and you clear that timeout somewhere in one of the later loaded JavaScript files. And if the timeout was fast enough, the callback of the timeout will be called and you know that the callback would be called. I found that a good place to put the second one, the clearing of the timeout, would be the polyfill TS file. Because first of all, it's, if you look at how Angular CLI creates your application, it's the second JavaScript file to be loaded. The first one is inline.js, and the second one is the polyfill TS file, or polyfill.js file. And the most important part, it stays roughly the same. So you're not going to change the polyfills every week or every day or something like that. And with that in mind, you can think of the polyfill size, polyfill.js size, and say, okay, to load 60 kilobytes, if I just measured it out, if you're on a slow connection, it takes you 2 seconds or something like that. If you're on a fast connection, it takes you 500 milliseconds or so. So you're kind of always the same. You have to crunch the numbers only if you're changing the polyfills. So if you remove or add polyfills. So how does it look like in your index.html file? I just, for example, used 2 markers and 2 timeouts. The first one is, I call it the slow timeout because it waits 3 seconds. The second one just waits 500 milliseconds. And what happens if the clearance of that timeout token is before the 3 seconds end, the function won't be called, so slow marker would be false. If it turns out that it's took me longer than 500 milliseconds to load the polyfill.js file, the fast marker will be changed from false to true, and now I know it. So there's no real magic, that's super simple. And afterwards you can look into all the booleans you created and say in your custom preloading strategy, okay, I had a slow marker true, I'm a slow connection, I had a fast marker true, and a slow marker false, so I'm a kind of a fast connection. You can verify with the numbers and the numbers of timeouts you're using this. This, again, is not to do a precise prediction of your internet connection, because it also takes into account how fast your browser or your machine can interpret the JavaScript you're executing. So the execution of the JavaScript is also part of it, but that doesn't matter for us, because if you're on a low-end device and your JavaScript takes quite a while to parse and to execute, that's also a good sign for us, because slow internet connection, low-end device, kind of falls into the same bucket where we really want to think about what we want to load. Second approach, if you don't like the timeout thing, is to use variables, global variables, and set the time in the index.html file and set the time in a later loaded JavaScript file. Again, the polyfill file would be a good candidate for that. You're seeing where I'm going with that. I start measuring I stop measuring, and then I see the difference of, I take the range of the end time and the start time, and I have a number. So the difference between those two is I have a number, I can play around with the numbers in the custom preloading strategy. The other one just plays around with Booleans. If you can think of anything else using those two techniques, it's totally fine, do it. And again, we're not predicting the Wi-Fi connection or the internet speed itself. We are kind of trying to get a feel for how fast our users' browser are and how fast their internet connection is. The thing is, there are techniques out there how to do prediction of the internet connection. Everybody who used something like speedometer or something like that maybe know them, where they are going to download a bunch of files and upload a bunch of files, and afterwards they give you a number. For example, you're on a 16 megabyte per second connection, or you're on a 2 megabytes per second connection. Those numbers are bits per second, and I explicitly didn't do any math to say that I'm on bits per seconds. Those techniques would also work. You could implement them in JavaScript, but that would mean that you're loading a lot of files down and up. And if you're on a slow connection, you don't want your user to download and upload stuff just for you to know if he is on a fast or slow internet connection. Second approach, low-end devices. I had the luck, I know that my colleagues from the content team, I know my users, so I know their machines, I know what they are doing. But if you do not know your users, do not know what machines they are on, wouldn't it be awesome if there's an API to detect if you're on a low-end device? Well, unfortunately, there is no real API that says you're on a low-end device, you're on a high-end device. Probably because that would have a lot of discussion of, I am not a low-end device, I'm a high-end device or something like that. Well, you can get this information by looking into various other APIs, like, for example, again, the window navigator. It provides you with a lot of information. If you ever looked into how fingerprinting is done, fingerprinting is the technique to detect your user without a cookie just by looking at all his APIs and saying, okay, I've seen this browser with this operating system with that many cores and stuff like that. This is definitely Martin's computer. We won't go into deep. We have a look at just those three. I found them to be very useful. Hardware concurrency is available in a widely range. Not all browsers have it, but you can get it. What it returns is the number of logical CPUs. So, for example, my computer is a quad-core computer. It would return the number 4. If I use it on a other machine, it would return 1 if it's just one logical core, or 2. And that's good information. So most of the times, if you see something like a quad-core or 8-core processor, you can think of a high-end device. If you see a low number, you're probably on a low-end device. Also, you can include the user agent. Everybody used the user agent probably once in their lifetime. It is a string that holds the information, what kind of browser do you have, which version of the browser do you have, and stuff like that. Also platform, it provides you with the information what operating system you're on. So if you're on a Linux or on a Mac or something like that, you can know just based on those informations if you're on a low-end device or on a high-end device. So if, for example, I see I'm on a Intel Mac, and I'm on a Safari, I probably on an iPhone or on a Mac with a Safari. If I'm on a just by statistics, if I'm on a Mac and a user agent is a Chrome, I'm probably on a desktop machine because the number of Chrome users isn't that high. on the iOS part. So this can really help you to determine if your user has a low-end device or not. Thirdly, user behavior. This is where I really kicked in with the problem I saw at my company. We want to know what the user does in our application, and we want only to load those lazy loaded files, lazy modules that are needed, and not everything else. For example, you don't want to load the admin panel and all that stuff if your user is not going to be in the admin panel. Because what happens if you don't load it and you're on a low-end device, it may just take a little bit longer if they are going to that module and your prediction was false. So this is really good for large applications with a lot of lazy modules. I want to go to solve that problem by going from the easy to the more difficult part. The easy part would be linear user navigation. What I mean with that is your application is kind of a funnel. So you can only access the next lazy module if you're on one module, and after that the next. So if you look at the image, if you're here, the next module you can access is this one, the next module you can access is this one, and so on and so forth. So what that means your custom preloading strategy would say, okay, I'm in module A, let's load module B. I'm in module B, let's load module C. Oh, the user didn't want to go to module D? Well, but who has an app that works like that? Anyone? Really? Awesome. In reality, it's a little bit more difficult. Because reality looks a little bit more like that. You have a module here, you can go to that module, you can go there, you can go to this view, and you can go back to that view. Probably if you have a navigation on the top of your app where you can go to all modules, this net would be quite would have quite more transitions and more edges. That's just for simplification. When I drew that on a paper, I thought about, well, I studied math, I did a lot of computer science on machine learning while I studied, and I love machine learning, so probably solve it with machine learning. I want to demystify a little bit what machine learning really is by introducing to machine learning in a nutshell. Every good developer or speaker should at least once reference Wikipedia. That's my personal opinion, because I wasn't allowed to do that in university. Machine learning is more or less just a bunch of algorithms that are able to learn from data and do a data-driven prediction or decision. So what we learn, it's not only one algorithm, there are many out there, and we want to do a prediction. That sounds good. We want to predict what module to load next based on data. The first group bucket would be classifiers. Classifiers like linear regression, naive Bayes, and decision trees. They need labeled data to train. So some human has to go there and say, okay, this email is spam, this email is not spam, this email has an invoice, this email has a cancellation. And you have to have a lot of that. And if you have that, you can train your algorithms, any of those. And the goal is to label every new data you get. So every new email, you want to think about, oh, this could be in spam now, because I've seen 1,000 spams. I'm certain that this is also spam. And what is really good about the classifiers, or especially those classifiers I showed you, they're really easy to visualize. So if you're going to your product owner and tell him, well, I have this decision tree, and you draw it, and it looks like a flow chart. Or if you're going to tell him, I've done linear regression, well, it's a line, it's nothing else. And you're just saying, okay, data on the left or data on the right. So it's really easy to start understanding machine learning if you're going to understand classifiers, because they're really easy to grasp. And for example, you can use them, as I just mentioned, with spam detection. And yeah, the second one, sorry, clustering. for example, the k-nearest neighbor, you use those kind of machine learning for clustering labels that don't have a data. You create piles of similar data. And you can use that for recommendation systems. For example, if you're an Amazon and it says, you bought this, maybe you want that. The most important one are neural networks. You hear them all the time. They're the buzzword everywhere. There are many variations of neural networks. They also need labeled data, so also a human has to look at this is a house on the picture, this is a car on the picture, this is a chair on the picture. And they're hard to visualize. You would use them for image recognition, for example. And the thing that popped into my mind when I saw that net were Markov chains, or in specific hidden Markov models. I'm going into Markov chains because they are a state machine with probabilities on each transition. And if you take the past into account, so if you think about, okay, my user started here, he got there, the probability will change just by the path the user took, and you have a hidden Markov model. You know those things too. If you have a phone and you're doing the autocomplete on your phone, that is hidden Markov models because it determines what word to show you next based on your on the words you typed before. So, how would a Markov chain look in our use case? You've seen that. That's the simplified small version of a net of transitions from lazy modules to lazy modules. And to make it a Markov chain, you just add probabilities. So for example, the probability to go from module A to B is 80% or 20% to go to module C. That looks really good. You can easily understand that, but it's not that good for our machines. Machines would love to have something like that. That's a two-dimensional array where every row is a module and every column is a module. And the thing is, you have the transition from A outgoing to B is 80%. So if you're in A and you want to know where to go next, you just have to have a look into a line like that and see, okay, from E to A is 10%, from E to B is 9%. What I also want to mention, those rows have to sum up to 1. The columns do not have to. I'm a little bit out of time, so I will go shortly into how to get the information. Google Analytics, if you have Google Analytics on your application already, fine. Maybe you find enough information. If you're more into open source, go to PVik, what is now known as Matomo. Or if you don't have anything like that, just create a small cloud function and post every transition from one module to another to that cloud function. If you want to build hidden Markov models, you can also take into account how you came from one module to another, but for Markov chains, that doesn't matter. So, a little bit of code. What I want to say to you is machine learning is not difficult because we have our two-dimensional array. We fill this two-dimensional array in some way with the probabilities to get from one module to another. That's the two-dimensional table I showed you just a few slides before. And we have a behavior subject that emits always a value with the next predicted module. So every time you get on a new module, you go to call this function with your current name, and it will predict here the next module and give you the information and push it to the next state. And what you can do in a preloading strategy, in a custom one, is you inject this Markov model service, and you're going to say, okay, I'm listening to this stream. It's an observable, the stream of predictions, what to load next. And whenever my name is up, I'm loading this module. So with this, I'm really able to do preloading based on machine learning, based on a machine learning model, and make it so that my user only uses what is probably his next decision to go for. So, conclusion. I'm out of time. Use it for large applications. Use it if you have a low-end device. Use it when you have slow connections. It can really improve the perceived performance. I said perceived performance because it also includes improves your real performance if you don't have to load megabytes over megabytes if your application is really large. And be aware you have an overhead. Collecting those data, doing the math to create this two-dimensional array, it takes some time. Every time you change your polyfill TS file, your timings with the timeouts or any other technique I showed you with the to detect slow connections will be out of sync. So you have to do a little bit of thinking about what you're doing. The math behind it isn't really difficult. If you're going to hidden Markov models, it's a little bit more difficult, but Markov chains is a really easy way to start it. Thank you.